All right, so this question is really challenging, and really, I put it on here because I wanted you to get exposed to the challenges. But if you get the basics set up and work through a little bit of it, that's great. But let's go ahead and take a look at how you can actually work through the whole thing. So for this thing, we know that it is a triangle. So that means that the sum of the interior angles, which they give you there, has to add up to be 180 degrees. So I'm going to go ahead and write those things up. So I have 9 times the square root of 2x plus 17. That's one angle, plus another one would be 9 square root x, plus the third angle, which is 12 square root x, and then plus 33. We know all that equals to 180, okay, or adds up to 180. And so for this thing, if I want to go through and actually start to solve this thing, I can see right away that in terms of moving stuff over here, the 33 can just be moved to the other side. And I'm just going to end up now with the 9 times square root of 2x plus 17. But I also should realize here that in terms of like terms here, 9 square root x and 12 square root of x, those are like terms. Like it could be like 9 apples plus 12 apples, 21 apples. So it's still just going to be 21, and then square root of x is essentially the variable attached to it, if you want to think about it that way. So over here I'd end up with 147. Okay. Now I'm taking a look at this thing here. This is kind of weird just because there's 2 square roots, but if I'm looking to make this a little bit easier on myself, I'm going to go ahead here and try to divide through by 3, because 3 goes into 9 and 21. Just makes things a little bit easier. And 3 also goes into 147, so that also makes things a little more accessible here. So I have plus 7 square root x equals to, and that comes out to be 49. Okay. So from here, one of the things that's going to come up is if I try to square both sides as it is, I could do that, but remember, you can't distribute exponents over addition and subtraction. So what I'm going to do here is I'm just going to go ahead and move this 7 square root x to the other side, and you'll see why in just a second. But the reason, square root of x, I'll rewrite this thing. So I have 3 square root 2x plus 17 equals to 49 minus 7 root x. So when I take a look at this thing, now if I go to square this left-hand side, and I have to do the same thing to the right-hand side, the left-hand side works out really nicely because now I can distribute over multiplication, meaning to each of the factors, so it becomes 9, and then if you square or square root, those things essentially undo each other, so I'd have 2x plus 17 left over when it's multiplied by 9. Now the right-hand side isn't as easy to work with, because if I square that, what that means is that I'm going to end up with essentially doing the squaring a binomial, or another way to say it is to FOIL it. And what you're going to end up with is 49 squared plus 2 times negative 7 square root x times 49 plus 49 squared. Now, all I really did there was using the idea that a plus b is equal, or the quantity squared is equal to a squared plus 2ab plus b squared. So I'm just using that idea as a model for getting this part here. Okay, so so now that we have that, we've gotten rid of some of the square roots, or at least the square root on the left-hand side, but we're still stuck with that square root in the middle on the right-hand side. But before I even deal with any of that, I want to go ahead and do some simplification here, just so I can clean up the right-hand side. And I'll actually go ahead and distribute the 9 here on the left-hand side too. So I have 18x plus 153, okay, equals to, and then 49 squared is 2401, okay, minus, and then when I multiply 2 times negative 7 times 49, I end up with negative 686, and there's still that square root of x on there. And then I still have the 40, actually I have a mistake back here. Instead of being 49 squared, this is just going to be 49x in there. Okay, and notice that difference because there shouldn't have been 2 49 squareds on that side. But going back to the problem now, if I go through, also that bring the 49x down. Okay, now obviously as you're seeing me work through this thing, it's way beyond kind of what we've seen already. So just try to bear with me and follow the basic idea. That's really what we're looking for here in terms of comprehension. But really what I want to do now is I want to move everything that isn't a square root to one side, and everything that does have a square root in it, I'm going to move to the other side. So I'm going to move the negative 686 square root of x. I'll move it to the other side, so I have positive 686 square root of x. Everything else I'm going to move to the other side and combine the like terms. It actually works out fairly nicely. I'm just going to be left with 31x, 31x plus 2248. Okay, and I've done this already ahead of time, but I just combine like terms once I move things to the other side. Now if I take a look at this thing here, I'm back kind of in the familiar territory of having the option to square both sides, because if I square the left-hand side, that's really what I want to do is to get rid of that square root of x. When I do that, I end up with a really big number, but I have this 47,0596x, just x right there, equals to, and when I square the right-hand side, I end up with this, 961x squared plus 139376x plus 5053504. So that's a giant number there. Okay. Now, once again, I just FOILed the right-hand side or squared that binomial. Okay. Now we have a quadratic, and anytime you want to solve a quadratic, you always want to have it set equal to 0. So I'm going to move the 470,596x to the other side. So I just end up with this. 0 equals to 961x squared minus 331220x plus the 5053504. Okay. And now at this point, this is where if you remember quadratic formula or completing the square, you have those as options, but these numbers are really big. My suggestion is that we take a look at this thing on the calculator and use the calculator to find those solutions. And we'll go through that in class later on. But like I said, this is just an introduction and just how you can work through some of these questions. But when I used my calculator, I ended up with two numbers, two solutions. X equals 16, which is nice. And then the other one was 328.66 approximately. This one doesn't work, the second one that is, because if you plug that back in, you end up with numbers that exceed the sum of the angles being 180 degrees. So the problem didn't ask just what was x, it asked us to solve for the angles. So if 16 is equal to x, that means that my three angles that I end up with here are 63, 36, and 81 degrees, which means that this is in fact a scalene triangle. Okay. All right, look at us, put in the honors and honors algebra 2. If you made it this long through this, awesome. The basic thing I want you to take away is remembering that the sum of the interior angles, the measures of the interior angles of a triangle is 180, and then really working towards the understanding, long-run understanding for this kind of thing here too. Okay, thanks a lot.